perfect squares, either in your head or on paper, it should be pretty easy to break down the 800. All right, but we want to look at the largest factor of 800 that's perfect. So if I do that whole x squared thing in my calculator and start off with half of 800 and work my way down from there, I should get the best perfect square factor of 800, right? Because you look at 800 and you say, well, 100 is definitely a factor of that, and that's perfect, but is there a better one? So I always start off with half, because it can never be larger than half of the given value, the radicand. So I go for half of it. If that happens to be a perfect square, then I have it. If not, I start working my way down the list from there to see if the number, or any number, is a factor of 800. How do we do that? We divide. We take the 800 and divide it by whatever we suspect to be a factor. All right. So turns out 400 is exactly half of 800, so that's perfect in more ways than one. So square root of 400, square root of 2, the square root of 400 is 20. Radical 2 you can't do anything with. All right. So that 6 is still there. Can't just disregard that. That's a multiplier. A coefficient is a multiplier or a constant multiple. All right? So it's part of a product. So I have to multiply this resulting expression by 6. But just like yesterday where we couldn't divide a rational number by an irrational number and vice versa, you can't multiply a rational number by an irrational number. You can only multiply rational numbers by other rational numbers and irrational numbers by other irrational numbers. That's why we're able to do this step here, because the square root of 400 times the square root of 2 is the square root of 800. But if I had something like the square root of 400 and just a 2, that would not give me the square root of 800. All right? Long story short, we need to multiply the 6 by the 20, giving us 120. So 120 radical 2. All right. So whatever that coefficient is there gets multiplied by whatever the new coefficient is. All right. So a little blurb here. A quotient with a square root in the denominator is not simplified. That's textbook jargon. It depends. It's a matter of perspective. Sometimes it's actually simpler than what it would look like if you were to quote-unquote simplify it. To simplify these expressions, multiply by a form of 1 to get a perfect square radicand in a denominator. The process is called rationalizing. That's really the standard way of thinking about rationalizing, but it's really not 100% accurate. It's just what everybody does, even though it's not right. So if you have a fraction that's entirely contained within a radical, that can be simplified further, right, using this rationalization process. Right? If you have a radical in the denominator of a fraction, but that radical is already simple, right? You broke it down and you canceled whatever could be canceled, then you can leave it like that unless the directions explicitly tell you that you can't have a radical in the bottom of the fraction. So on an assessment, it would say something like, simplify this radical so that there is no radical in the bottom of the fraction. You know, the grammar will be a little bit better on the assessment, but you get the idea. All right? So, but that's not going to be for every problem. That's only one instance because it's a skill. The skill is rationalizing to take a radical from one part of a fraction and move it to the other. So we can rationalize a numerator or we can rationalize a denominator. So a question could also tell you to, and it will, this isn't foreshadowing or anything, it's just me explicitly stating it. I'm going to say I want the answer with no radicals in the bottom, and then I'm going to give you another problem where I don't want a radical in the top of the fraction. Right? So, and then there's going to be plenty of other problems where it's like you can put the radical wherever you want as long as it's in simplest form. Right? But for now, we're just going to focus on rationalizing the denominator. All right? And later on, I'll show you the other way. All right? So the way we handle this, first off, if you have a fraction entirely contained within a radical, it can be thought of as radical of the top divided by radical of the bottom. Those are equivalent expressions. All right, these two things mean the same thing. All right, so you could actually go the other way also, where if you had a radical over a radical, you could just put a radical over the whole fraction. All right. Now that radical 25, the square root of 25, that's perfect. Square root of 25 is equal to 5. Square root of 7 is the square root of 7. There's really nothing you can do with that, except to rationalize. All right, so if a question doesn't tell you to rationalize the denominator or that you can't have a radical in the bottom of a fraction, then you could just leave it like this. All right, but if you need to rationalize, and I'll say remove the radical from the denominator. We're not just going to say, okay, well, I'll just take the radical and make it disappear. You got to do something operation-wise to make that happen. All right. So we have 5 over radical 7. One way to get rid of a radical would be to multiply by that same radical. All right. And I'll show you why that works in a sec. If I multiply the bottom of this fraction by a radical 7, and I'm just focusing on the bottom for now. If I multiply the bottom of the fraction by radical 7, I get radical 7 times radical 7, which is, you can think of it 2 ways, radical 49, or you can think of it as radical 7 squared. Either way, the result is 7. All right? So radical, I'll say 49, which is 7. The hope is that you would jump from this directly to that without showing that intermediate step. All right? But you can't just multiply the bottom of a fraction by whatever you want unless you also multiply the top of the fraction by that same expression. All right? That's to keep equivalence. It's unreducing. Right? It's equivalent to, like, if I were to take a 1/2 and multiply just the bottom by 2. That would be 1/4. That's not the same as 1/2. But if I multiply it by 2 over 2, that's 2/4, which is the same as 1/2. I haven't changed its value. I only changed its appearance. All right? So I'm going to multiply top and bottom by whatever the radical is in the bottom of the fraction. So 5 radical 7 would be the result. Right? When I multiply the top by radical 7, it's a rational and irrational number being multiplied. I can't actually multiply them. The only thing I could do is write them adjacent to one another. Right? So that's just going to carry on through and give me a result of 5 radical 7 over 7. That's why this statement here is such a weird statement. And, you know, like every textbook has something like this. But it's not correct, because, I mean, just look at it. Look at what we had before we rationalized, and look what we have after we rationalized. Which one looks simpler? The one with less stuff. Right? But some people define a fraction as being simpler if it doesn't have a radical in the denominator. That's not correct. All right? So it's just the way the Regents does it, and that's the way they expect it. So we have to kind of do it the wrong way for a little while.
So if we were to do a test on this, would we do the simpler way for you and then the harder way for the Regents, or should we just practice the harder way so we kind of get in the habit?
It's up to you. For me, I'll accept it either way. So, but there will be instances where I'll tell you, because it's a good skill to have, rationalizing. So there will be instances where I tell you to rationalize the denominator, but there will be other instances where I say just express your answer any way you want as long as it's simple. So you can decide for yourself. So number 2, we can approach this the same way, but it's kind of a little different in that number 1, 25 and 7, they didn't have a common factor. When you see a fraction, hopefully one of the thoughts that cross your mind is to try to simplify. Like reduce the fraction. Maybe not all the time, but that's a good habit to get into. You see a fraction, you think, okay, well, what would happen if I simplified it? Well, both of these terms, the 5 and the 15, are divisible by 5. So this would reduce down to 1 over 3. All right, if you don't recognize that, I apologize if I didn't go over this yesterday. You can put a fraction in your calculator and have it reduce it for you. There's 2 ways to do it. One is the math frac, which I'm pretty sure I did go over. The other way is alpha y equals the n over d. Bless. So if you pop in whatever fraction you have without the radical and hit enter, it'll simplify it for you. It'll look nice in the process. So I didn't do that with number 1 because 25 and 7 don't have a common factor, so there was no value in doing that. All right. So in doing this step, we're able to work with simpler numbers, knowing that a radical of a fraction is the same as the radical of the top over the radical of the bottom. This gets us to 1 over radical 3, which is a nice, simple-looking answer. But by the rules of people who don't know math, it's not simple enough. All right? So if you need to rationalize the denominator, then what you would do is you'd take that 1 over radical 3. I need to get rid of the radical 3 on the bottom, so I multiply by itself. But I can't just multiply the bottom of a fraction by a number without also multiplying the top of the fraction by that same number. So on the top, I get 1 times radical 3, which is just a clean radical 3. On the bottom, this is the step that I was saying earlier that I would hope that you would skip. Radical 3 times radical 3 is radical 9, which is a 3. So why not just write the 3? All right. So whatever the radicand is of your denominator, that should end up being the new denominator, unless there's a coefficient, which we'll get to right now. So looking at number 3, I mean, it's already broken apart. It's not one single radical. It's broken apart. You look at it and say, well, there's no common factor, whether it's for the rational numbers or the irrational numbers. So the radicals or the non-radicals and the radicals. So what do? Well, really the only thing you could do if you're trying to get it into a different form is to rationalize the denominator or rationalize the numerator. All right, so I'm going to go over that process here. So there's 2 ways that you could change the look, the appearance of this fraction. You can rationalize the numerator you could rationalize the denominator. All right, so we'll go with the thing that we know already. We know how to rationalize the denominator, so we'll tackle that one first. All right, so I need to multiply the top and bottom of the fraction by whatever the radical term is in the denominator. I don't have to multiply by the entire denominator. That's a common misconception. All right? So I'm not going to multiply top and bottom by 2 radical 2. You'd eventually get the right answer if you did that. It would just take a little longer. You only need to multiply top and bottom by whatever the radical factor is in the denominator. So radical 2. All right, so the 3 on the top doesn't get multiplied by anything except for the understood coefficient of 1 in front of this radical. So we're going to have a 3 in our numerator. Radical 5 times radical 2, well, those I can multiply because they're both radical. That's going to give me radical 10. And it won't be something I'm able to simplify. Right? It's product of prime numbers. None of those prime numbers are perfect squares, so that's the end of that. All right? But on the bottom, same deal. I'm going to multiply the 2 by the understood coefficient of 1 here and get a 2. But now this radical 2 times the radical 2 will give me just a plain old 2. Or if you want to show the intermediate step, radical 4, which would then become a 2. All right. So we have 3 radical 10 over 4 as a final answer, if we had to rationalize the denominator. Same value as the original fraction, just without a radical in the bottom. So we could have also rationalized the numerator. How do you do that? Same way, except you're trying to get a radical out of the top of the fraction. Right? There's value in that skill also. So 3 radical 5 over 2 radical 2. So I would take whatever the radical is in the numerator and multiply that by the numerator. But I can't just multiply it by the numerator without also multiplying it by the denominator. So each of these radical 5s have understood coefficients of 1. Tuck them in there if you want. You can multiply the rational numbers by the rational numbers and the radical numbers by the radical numbers, but you can't mix. All right? So 3 gets multiplied by the 1. The radical 5 gets multiplied by the radical 5, giving you, as an intermediate step, radical 25, which is the same as saying 5. Then on the bottom, 2 times 1 is 2. Radical 2 times radical 5 is radical 10. So we're looking at 15 over 2 radical 10. All right. So one of them has the radical exclusively in the denominator. The other has it exclusively in the numerator. And the original one that we started with, which looks like it's probably simpler than both of the things we just came up with, has a radical in the top and the bottom. Right? They're all simple. None of them are wrong. It's just a question of what you're asked to do.
So, like, 15 over 2 radical 10, that could also be rationalized. But since that's an answer, like, of, like, that is a rationalized version of, like, you know, that, like, should we rationalize it?
Only if you're asked to. Yeah, because if you were to rationalize that further, like, let's say for this result, if you were to try to get the radical out of the bottom, the only place you could put it is in the top, and you would come up with just this answer anyway. Yeah, so you're going to bounce, no matter what you do, you're going to bounce back and forth between these 3 fractions, whether you rationalize the top or the bottom or neither.
So you're always going to have at least one radical?
Yeah, if there's a radical in there, there's always going to be a radical in there.
So when we're like doing these problems, do you prefer if we should rationalize the denominator and the numerator? Like, do you have a preference or regions?
My preference is always the one that looks the simplest. So just going back to like number 1, or even number 2, well, more so number 1. you have the 5 over radical 7 versus the 5 radical 7 over 7. The one that has less stuff is the one that's really simplest. So the 5 over radical 7 is the better one. Right? In this case, they're all ugly. It doesn't matter what you put down for a question like this. So for a problem like this, you would just look to follow whatever instructions are given. Because if there are no instructions given, if it just says to simplify, you do whatever you want, and it's going to be okay. The thing about a question like this is that this is most likely a multiple choice. Which of the following is not equivalent to 3 radical 5 over 2 radical 2? It's along those lines. So you wouldn't really have to worry about instances where it's like, well, he didn't tell us what form to put our answer in. What do I do? In those instances, if I don't tell you what form to put your answer in, you put it in whatever form you want, and you're right, as long as you do it right. Right? The instances where I say rationalize the numerator, rationalize the denominator, obviously you have to do it that way, but everything else will be multiple choice.
Is that a fraction? Like, is there a way to simplify the fraction on Desmos?
Oh, on Desmos, yeah. Let me pull that up. Oh wait, sorry, you said fraction, not radical. Duh. That's even easier. So I'll do the 5 over 15. So 5 divided by 15. It'll give you a decimal form. All you do is tap on that fraction icon, and it'll simplify for you. I was about to go into a whole thing on simplifying radicals on Desmos. So number 4, you look at this, and you see a radical 3, a radical 48. The first thing that you should look to do is to try to simplify the fraction, right? Because they're both radicals, right? Whether you write it like this, the way they give it, or one single fraction under a radical, they're equivalent and simplifiable, right? So if you do it on the TI, 3 over 48, you get 1 over 16, which is really the best possible outcome. All right, because we could write this as the square root of 1 over 16, or we could write it as the square root of 1 over the square root of 16. They both mean the same thing. Then we could go the extra step because 1 and 16 are both perfect. The square root of 1 is 1. The square root of 16 is 4. Sometimes you get an answer that starts off as a radical and ends up not being one. And that's nice. That means that this whole thing, it's kind of like, I don't want to say a trick question, but it's along the lines of like a disguised rational number. Like it was always rational, it was just in a different form. So you could always, if you want, you don't have to do it this way. But if you put in whatever radical you're given, whether it's fraction or otherwise, into whether it's Desmos or TI, give it a quick look. If you get a clean answer, then you got your answer. It's when you get an ugly decimal, that's when you know you have to do some other work, or most likely anyway. So let's say that this is a 47 instead of a 48. Hideous decimal, that means it's irrational. Hideous decimal, again, never repeats, never ends. All right? If you get a clean decimal, so something that ends or repeats, then you're looking at something that's rational and it won't have a radical in its answer. Right? So you look for different situations like that. And sometimes just carrying out that quick operation gets the job done. But if you try that on number 5, you might run into a little bit of trouble. It's not really that bad, but I'll just do this the old-fashioned way. You get that decimal and you're like, oh, what is this? This is nasty. Right? But really, that radical 12 over radical 4 is the same as radical 12 over 4. 12 divided by 4 is 3. And that's all there is to it. So that's kind of nice. There's little tricks when it comes to radicals. I mean, some of them work very well, and some of them are just not useful all the time. But one thing I do like to do is if I have a situation where I know the answer is going to involve a radical, what I'll do is I'll pop the radical into the calculator, get the hideous decimal, and then square it. That's the number that has to be under the radical. Sometimes it doesn't work, so it's not always useful, which is why I don't really promote that too much. But, yeah. So when I look at, well, actually number 6 is really clean, so I'll come back to that idea in a minute. Yeah, because number 6, radical 20 divided by radical 5 is radical 4. Square root of 4 is 2. I mean, if you just pop that into a calculator straight away, you would have got that answer, but that's one of those instances where doing it by hand is actually quicker than even typing it into the calculator.
Is there more than one way to get an answer? Like, because I realized when you were doing the numerator versus denominator, there are 2 different answers. Would that work, or how is that like calculated for?
Are you talking about for these kind of problems?
Yeah, for these kind of problems. Like, I saw one of the problems when you did numerator and denominator, like the different like ways of doing it, it had different end results.
Yeah, in these cases, because they're much simpler, like there's no need to rationalize because in each one, number 4, 5, and 6, each one of them involved a perfect square in some way. And because of that, it's simplified down to a pretty clean answer. But we could, so 4 and 6, because they're rational, that would be irrelevant. But we could change up number 5, for example, because number 5, we have radical 3. That's the same as radical 3 over 1. Right? If I wanted to rationalize the numerator, I could multiply top and bottom by radical 3. And that would give us radical 3 times radical 3, which is 3. 1 times radical 3, which is radical 3. Right? So radical 3 and 3 over radical 3 have the same value but a different look. So that would be an instance where you'd have different looking answers, but that are equivalent. So basically, if there's a radical in your answer, you could have multiple ways of expressing that final answer. It's when you don't have a radical in it. That's when it's just cut and dried, one way to express the answer. No problem. So let's see. We'll do one more, I think. So number 7, that's along the lines of, I think it was number 3, where you have a radical in the top and the bottom. That 8 can be simplified. So it's a question of what do you want to do first? Do you want to simplify the individual radical and go from there? Or do you want to look at that radical 6 and radical 8 separately, as part of a fraction? So like I would just pull it apart and just kind of focus on this piece here. Ignore the 4 and the 3 for now. The radical 6 over radical 8 is the same as radical 6 over 8. 6 over 8 reduces to 3 over 4. Which in turn, if you split it up, becomes radical 3 over radical 4. Which in turn becomes radical 3 over 2. Square root of 4 is equal to 2. So just a progressive approach where it's just taking a piece out and then following the process through to a natural conclusion, but then circling back to replace that expression, the one that was removed, with the new simpler expression. So we could do it that way. We could also simplify this even further because the 2 will divide evenly into the 4. 2 goes into 4 twice. So we would have 2 radical 3 over 3. So that would be one way to express this answer. All right? So it's clean in the sense that it doesn't have a radical in the bottom. But if we wanted to have a radical only in the bottom, then I could take my 2 radical 3 over 3 and rationalize the numerator by multiplying it just by the radical part of the numerator, which is radical 3. 2 times the understood 1 in front of the radical 3 would be 2. Radical 3 times radical 3 is just 3. And then you'd have 3 radical 3. Now here you have a common 3 that can be canceled. So 2 over radical 3 would be the result. All right, so these two expressions are equivalent to one another and equivalent to the original expression, the original radical fraction. But out of all 3 of these possibilities, the simplest looking one would be the 2 over radical 3, right? The one where we rationalize the numerator. Right? So, and again, bless you, without explicit instructions on which form your answer should be in, as long as it's simple, you're fine. It's just, it's kind of, sometimes it's hard to see what is simple enough. All right. So if you've reduced your fraction as much as you can, and you've simplified your radical as much as you can, then you're in a simplest form. It's just a question of whether or not you're in the simplest form that you're being asked to be in grammar. So that's that. We're going to practice with this for another day. So what I'm going to ask you to do is, nothing to submit again. Tomorrow I'll ask you to submit something. I need some time to get caught up with the grading and stuff. But page 25 for homework, if you would.